Okay, this is the solution to question 9 in exercise 27.1 of real world physics. So we have a straight piece of wire of length 3 meters. So I'll write down what we know. The L is 3 meters. The current is 3 amps. The magnetic flux density is 2 Tesla. And we have to figure out the force on the wire. But the wire is at an angle of 30 degrees to the magnetic field. Now normally we would do this BIL where it was 90 degrees because that's when you get maximum force. We're going to be using the one we use BIL sine theta, but I want to just draw it and explain it a little bit here if you don't mind. So we have our magnetic field doing this and 30 degrees. So here is my wire, okay? I'm going to say I is traveling along that. And then this down here is theta. It's making an angle of 30 degrees. I know it's not 30 degrees, but we'll imagine that it is, okay? So what I want to do is figure out how much of, from the current's point of view, right? Some of the magnetic field is going to be parallel to it and some of the magnetic field is going to be perpendicular to it. So for one of these arrows, we can split it up into dot, 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 and dot, 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 dot. So there is this B that is perpendicular to the wire, and this is B that is parallel to the wire, okay? So we're breaking it up into two different components, all right? So the B that's perpendicular, because it's on the opposite side, that's the same down here, there's B perpendicular. Because it's opposite to my angle, I'm using sine of theta. If this is my hypotenuse in the middle there, then it's going to be B times the sine of... Rian, out you go, buddy. Thank you. B times the sine of the angle, right? So because we know that sine of theta is the opposite over the hypotenuse, right? In this case, the hypotenuse is B. So the opposite, this component that is perpendicular to my wire, which is the one that causes the effect. Because remember, when we're talking about we were assuming the magnetic field is perpendicular to the current. So how much of my magnetic field is perpendicular? Well, I can say that the opposite side, which I'm calling B perpendicular, is equal to the hypotenuse multiplied by the sine of the angle it's making. So that is essentially that B perpendicular is equal to full strength B multiplied by the sine of 30 degrees in this case. Okay, so all I need to do now is plug that in. So the strength of the force that's acting on it is going to be, I'm not going to copy it exactly, I'm going to just rewrite it using this method down here. So it's my 3 amps multiplied by my 3 meters multiplied by my 2 Teslas, but not all of the 2 Tesla, it's 2 Teslas times the sine of 30, okay? So it's 3 times 3 times 2 times sine 30. I hope I'm in degrees, I am. And I get an answer of 9 newtons. Okay? And then the second part is, what is the force on the wire? At what angle would the force on the wire be 0? So that would be theta equals 0, because if, in that situation, here's my wire, I, and if all of the B, I should have used different colors to this, but it doesn't matter. All of the magnetic fields are, if all of the magnetic fields are parallel, then if I turn it through 90 degrees, there is no component of B which is perpendicular to my wire here. This being the wire that's traveling through the magnetic field. Okay, this thicker part here, there is no component of B that is perpendicular, so this falls apart. This doesn't work, so there is no force. So that happens when the angle is 0 degrees between the wire and the magnetic field.